Hey everybody, this is Alex Merced from alexmercedcoder.com. And what I wanted to talk about today was garbage collection. Garbage collection is this whole idea of memory management that's kind of automated in generally higher level languages like JavaScript, like Python, like Ruby. And garbage collection has its pros and cons. One, you don't have to worry about memory management on your own, like you would with lower level languages like C++, where you have to kind of make an effort to manage your memory so that way your program runs smooth. But the downside is that's an additional process. Okay, so you avoid running out of memory, but now you have this additional process that's running that when you're running your code at scale can be an issue. Now the language Rust tries to find a way to kind of meet these two worlds together, where you have some elements of garbage collection, but they're kind of optional, so that way you can manage your memory manually, which means more coding. It's harder to code, but again, you could create a faster result at the end of the day. So let me just explain to you how this works in, let's say, JavaScript. So let's switch over to the screen. Okay. So the idea is that when you're doing garbage collection, it's not when you're doing it, but when the interpreter, the JavaScript, the Python, the Ruby interpreter, they're constantly taking a look at the variables that are on the screen. So right now, let's say I declare this variable const my var equals cheese. So this is a global variable. So this will never get garbage collected for the most part, because technically the way what it's doing is that it's looking inside the context of the global space and saying, okay, what information may be referred to? What data do you still need? Okay, so when I do this, this is always going to be in my memory, because technically, because it's in the global space, there's always a chance I might refer to it. Okay, so this is why you don't necessarily want to create everything as a global variable, not just for organization purposes and thinking through your code clearly, but also better memory management. Vice versa, if I did this, const my func equals equals const a var, we'll say equals 5. This gets declared here, but the minute the function's done running, I have no way to access this function outside of the function. Okay, so in that case, the garbage collector will be like, oh, okay, you don't really need this anymore. So in that case, I will dispose of it from your memory. It's like, oh, okay, cool. Now, what if I did this? Return, and I return a function that returns a var. Now, if I return this function and assign it to a variable, so const value equals my func. So even though this variable is scoped within the function, by exposing its enclosure to the outside world through this function, this is no longer going to get garbage collected, because now the software, when it measures your memory, sees, okay, there is a way for me to access this variable from outside this function. I'm not going to clean it up as long as this function exists. Now let's say I don't copy the function into, well, let's say I do want something like this. I just don't want to store it, because like the idea is that this function is going to exist in memory as long as this variable exists in memory, and this variable will always exist in memory because it's global. So what if I did this instead? What if I want to access that variable? So instead, what I do is I invoke the return function, but I don't save the function in the variable. This function runs. A var still exists, because technically this function just got returned by it. The function gets invoked. The function returns a var, but there is no reference to the function, so now the function disappears, and without the function, there's no reference to a var, so a var disappears. Okay? So the idea is, like, is there a way to get there? Okay, is there the possibility that this variable can be accessed at some point later in the program? That's essentially, and how it does this is a couple different ways. There's different algorithms for doing so. One that kind of starts from like the root of your program and determines what it does have access to and then gets rid of everything else, versus ones that take a look at your data and try to determine, basically bottom up or top down. Like the other way would be to start with a piece of data and try to work through its references and see if you can somehow work your way back up to the top. But either way, if you can't start from the bottom and get to the top, and if you can't get from the top to the bottom, then technically there is no reference. So in that case, you get rid of the data. This is why arrow functions are so important. So if I'm doing something like map, I could do this. I could do const map function, and map function equals, item, and all we're returning is item plus 1. Okay. And then we take an array, const 1, 2, 3, 4, 5, 6 dot map, and then for the map I pass the map function. So here's what's going to happen. Now actually, let me get rid of this const. This array, I don't store in any variables. So the minute this operation is over, it's going to map this function over this array, but this function disappears from memory because, again, I'm never going to refer to it again. Okay, there's no reference to it. There's nothing that allows this data to be accessible past this line of code. So it's going to get garbage collected. The thing is that this function does not. So even if this function, this is the only time I ever intended to use this function, the computer doesn't know that because this function still has a active reference to it. Okay, so in that case, that's going to be sitting there in my memory. So if I don't want that, if I'm only going to use this once, then what I'd rather do is this. Okay, so in this case, all of this gets garbage collected. So this array will run, this map function will run, but this function gets garbage collected because there's no reference to it going forward. And this array will get, and then I can store the results of this operation, const mutated array, but nothing, const mutated array, I get the result, but nothing I used to get the result will get saved around my memory. Because again, this array isn't stored and has no reference to it. This function has no reference to it. So again, the idea is don't give things names in the global space unless you plan on needing it more than once. Okay. And let's say I did maybe need this particular array more than once. It might be smarter to use a function. Where basically a lot of the data will get garbage collected, and then I can just rebuild the data when needed, and have that logic in a function, depending on sort of the level of what it is, and breaking it up into multiple functions. The idea is, having more operations occur in a function allows more interim data to get garbage collected, which allows me to have more explicit operations without having to worry about memory management. Again, in lower level languages, even if there was the reference there, I could still destroy it. I could still I know that I'm not going to use this function anymore, so remove it from memory. I could actually give it those explicit instructions in like Rust or C++. Can't really do that in JavaScript, Python, or Ruby. So then you need to think about how you structure your code to sort of minimize those references, to minimize your buildup of memory, so that way you don't eat up memory, which will result in a slower program as operations get more intense. So my name is Alex Merced from alexmercedcoder.com. Hopefully this helps you understand sort of memory management in JavaScript, Python, and Ruby, in the sense that basically it's less about you using explicit memory management more than coding in an efficient way that sort of facilitates the garbage collection that the language naturally does to maximize its ability to do its job. Have a great day and enjoy.